Welcome to Math Vision tutorial class once again. My name is Moses. In today's class, I shall be teaching you how to find the equivalence resistance in any given circuit. And this equivalence resistance is also known as the total resistance in a given circuit. We shall be considering this example on the board. But before we start, if this is your first time of watching my video, please subscribe to my YouTube channel and don't forget to click on the notification bell so you can be notified whenever I drop a new video. So now let's start with the example on the board. In this example, you see that we have about 5 resistors. We have 1, 2, 3, 4, 5 resistors. And we want to look at the total resistance that these 5 resistors will be contributing to the circuit. And by this, there are some processes we need to consider in order to be able to find the total resistors, the total resistance of the resistors in the circuit above. So now, before we do this, we need to check the connection between the resistors. Like considering 2 resistors at a time, what is the connection between them? If it is series, if it is parallel, then we combine them together and we continue the process gradually. But before that, we need to know that when 2 resistors are connected in series, the equivalence of the 2 resistors is simply the algebraic sum of the 2 resistance, that is adding the resistance of the first resistor plus the resistance of the second resistor. And when 2 resistors are connected in parallel, the equivalence resistance is simply the product of the 2 resistance, the product of the first and second resistance over the sum of the first and second resistance. So we'll be making use of this to solve this problem on the board. So now let's start. I need to consider 2 resistors at a time. I need to check the connection between the 2 resistors. If it is series, if it is parallel, then I'll combine. Now let's consider these 2 resistors, 10 ohms and 5 ohms resistor. What is the connection between the 2 resistors? The connection is series connection. Why? The reason is because if current is to flow from the 10 ohm resistor to the 5 ohm resistor, the current has only one path to take. The current has only one path to take to move from the 10 ohm resistor to the 5 ohm resistor, and in this case we say that the connection between them is series. But if we have another part, if there's another part here, we have a node. The current that is coming from the 10 ohm resistor has another path to take. The whole current cannot go to the 5 ohm resistor. So in this case, we say that the 2 resistors are connected in parallel if there's another path for the current to take. But here, the current has only one path to take and the 2 resistors are connected in series. So we need to combine the 2 resistors using this. And the equivalence of these 2 resistors, the equivalence is simply 5 plus 10, which will give us 15 ohms. So we can combine these 2 together. We can combine these 2 and we say that this is the equivalence of the resistors is simply 15 ohms. So now let's consider these 2 resistors. We notice that if current is to flow from 15 ohm to the 20 ohm, the current, there's a node here. The current has another path to take. The current at this point, some current can move here, some current can pass here. So the current has 2 paths to take before getting to the 20 ohm resistor. So we say that these 2 resistors are connected in parallel. And how do we find the equivalence of the 2? We are going to follow this. So now the equivalence of these 2, the equivalence is going to be 15 times 20 over 15 plus 20. And this is approximately, this is approximately 8.6 ohms. This is approximately 8.6 ohms. So we can combine these 2 resistors together. It means we don't have resistance here anymore. We can clean here, and also we can clean this. The equivalence now is 8.6 ohms. So now let's consider these 2 resistors now. These 2 resistors are also connected in parallel. Why? Because when current enters into this 10 ohm resistor and the current is to flow, for the current to get to this 8.6 ohm, the current has some other paths to take here. Some of the currents can move like this and some of the currents can move like this before getting to the 8.6 ohms. So now we say that these 2 resistors are connected in parallel as well. Why? Because the current has some other parts to take apart from this part. So now these two are connected in parallel. So we need to find their equivalence using this as well. The equivalence is going to be REQ, which is 10 times 8.6 over 10 plus 8.6. And this is approximately equal to 4.6. This is approximately equal to 4.6 ohms. So that is the equivalence of the two. So now we can clean this and we combine these two together. We clean this and we have this to be 4.6 ohms. So now let's consider these two resistors now. These two resistors are also connected in parallel. Why? Because if current is to flow from this resistor to this, the current has some other parts to take apart from this part. So the current has two parts to take before getting to 4.6. So we say these two resistors are connected in parallel. And now the equivalence now is going to be REQ, which is equal to 5 times 4.6 over 5 plus 4.6. And I'm pressing this on the calculator, so this is approximately equals to 2.4 ohms. So now we can see that the total resistance, or let's say the equivalence resistance of the 5 resistors is 2.4 ohms. And we can simply draw the circuit to be this. You can simply draw the circuit to be this, which is 2.4 ohms for this circuit. So the total resistance or the equivalence resistance is simply 2.4 ohms. If you find my video helpful, please subscribe to my YouTube channel and don't forget to click on the notification bell to get notified whenever I drop another video. So I'm going to see you in my next video. Thanks so much for watching. God bless you.